Okay, we're in section 8.2 where we're learning how to graph simple rational functions. So simple rational functions comes from the apparent function where f of x or y equals 1 divided by x. One thing we have to keep in mind when we're dealing with rational functions, especially when our variable is in our denominator, is we have to concern ourselves with what is called vertical and horizontal asymptotes. Vertical and horizontal asymptotes are what values of x and y that we'll get very, very close to on the graph, but we will never reach that actual number. And for the apparent function, it's x equals 0, and also x, and then for the horizontal asymptote, it's y equals 0. The reason for that, it's pretty obvious for the x equals 0 because you can't take 1 and divide it by 0 and get a defined function. If you punch it in your calculator, you'll get an error code, it'll be undefined, etc. The reason why y can't equal 0 is because there's no value that we can make up for x that'll make y equal to 0, because x is in our denominator, and if x was 0, that means we'd have to put, it would make it an undefined function, etc. So if we look, say if I were to put this in red, I'm just going to take the asymptotes here and put little dotted lines here, just to kind of represent what they are. They're not always on the x and y axis, but in this case they are. So now, again, it's just like what we've been doing before when we're graphs. We make a t-chart. I get x values, and so here I've given some x values, -2, -1, -1 half, 1 half, 2, and 1. And so if I plug those into this function, I'll get some values for y. So if x is 2, my y is going to be -1 half. If my x is -1, my y is -1. My x is -1 half, my y is -2. If my x is 1 half, my y is 2, and then so on. So this becomes 1, and then this also becomes 1 half. So here it's just a matter of plotting these points. So I'm going to go -2's, -1 half, right about there, -1 and 1, and then -1 half and 2. So it looks something like that. And then I make my graph. Looks something kind of like this. And then go to the other side. I'm going to go 2, 1 half. I got 1 and 1. And I got 1 half and 2. And then my graph looks something like this. So again, I got two different curves, and both of them are stopping at our vertical and horizontal asymptotes. In this case, it's x equals 0 and y equals 0. So when steps we want to do for making the graphs is first draw the asymptotes, figure out where they're going to be. Then I want to pick 3 x points to the left and right of my vertical asymptotes. Plot those x and y coordinates, and then draw our graph. So if I have y equals 4 divided by x, I have to figure out what is going to be my vertical and horizontal asymptotes. In this case, it's still going to be x equals 0 for the vertical one and y equals 0 for the horizontal. So I'm going to, again, put my dotted line here. So the red dashed lines represent our vertical and horizontal asymptotes. Second step they want us to do is plot points to the left and to the right. So they said 3, so let's do -3, -2, -1, and let's put 1, 2, and 3. Can't put 0 because that makes x and that makes y undefined. So if my x is -3, my y is going to be -4/3. If my x is -2, my y is going to be -2. If my x is -1, my y is -4. My x is 1, my y is 4, x2, y is 2, and x3, y is 4/3. So I get to plot these points. So I go -3, -4/3, I'm right there, -2, -2, and then -1 and 4, so 1, 2, 3, and 4, so somewhere right about there. So I get to plot these points like that. Next I'm going to go 1 and 4, 2 and 2, and then 3 and 4/3, so then now my graph looks something kind of like this. And again, we're just sketching. So that would be the graph would look like for y equals 4 divided by x. If I had y equals -6 over x, again, my my vertical asymptote would be x equals 0, and my horizontal asymptote would be y equals 0. So again, I'll draw out those asymptotes. They may not be as important right now because they're both 0, but it will help you when there's a transformation change, which we'll talk about a little bit later. Next, I'm going to make my x and y chart. Here, I'll just use, again, -3, -2, -1, 1, 2, and 3. And then the values I got for -3, I got 2, -2, I got 3, -1, I got 6, 1, I got -6, 2, I got -3, and for 3, I got -2. So I get to plot these points. So I'm going to go -3, 2, -2, 3, and 1 and 6. So it kind of looks something like this. And the next one will be like 1, -6, 2, 6, 2, -3. This should be right here, plotted incorrectly. And then the last one would be 3, -2. So now my graph kind of looks something like this. And if you noticed, my curve here is in the second quadrant and fourth quadrant, and then beforehand it was in the first and third. So that's dictated by, here I had a +4, and then here I have a -6. So if I have a negative value there, that changes the direction of my curve. So keep that in mind. Like I said, I talked about there will be graph transformations. Really doesn't, we've been talking about transformations before, and it still means the same thing. H is my horizontal shift, K is my vertical shift. And what this does is it tells us it's going to dictate what our domain and range are. So with the vertical asymptote is going to be dictated on what h is going to equal. So the vertical asymptote will be, well, I guess I could put it like this. It would be more like x will equal h. So that means when I write my domain, it actually will be all real numbers except x cannot equal h. And then my horizontal asymptote, my y, will equal k. And then same thing here. My range will be all real numbers, except y cannot equal k. So here, they want us to graph this function, and they want us to find the asymptotes and state the domain and range. So just by looking at it, my domain and my range here, again, my domain is going to be all real numbers, except x cannot equal, well, my h is 1, so my x cannot equal 1. My range will be all real numbers, except y cannot equal, and my k is 2, so my y can't equal 2. And that's dictated by what my vertical and horizontal asymptotes are. So I've said that x cannot be 1, so that means my vertical asymptote must be 1. So I'm going to make a little dotted line at the x equals 1. Horizontal asymptote cannot equal 2, so So those are my lines for my asymptotes. Now I can make my XY chart, and now I get to take values both to the left and to the right of my asymptotes. Here it's at 1, so I can take, values like -3, -4, -5. That's I can put on the left side, and on the right side I can put in um, well, about 2, 3, and 4. And so what I can do here now is I say, okay, I take -5, add that to 1. So -5 minus 1, that gives me what, 6? -3 divided by -6 would give me a 1/2. So -5 plus 1/2, well, 1/2 plus 2 would give me 2.5. And then if x is -4, -4 minus 1 will give me a -5, so that's what, 3/5 or -3/5. So plus 2 here would give me what, about 1.4. 3, -3 minus by, so that give me what a positive 0.75 actually would be. So if I have -3 minus, that would be what, zero point 0.7, so that's be positive 0.75, so that would be what, 2.75? I think I did something wrong here with the -4. So if I have negative, so that would be a positive 3/5. So, and then add 2, so that would be 2.6. Sorry about that, apologize. And then if I put 2, so 2 minus 1, give me 1. So that'd be what, -3 plus 2, which will give me what, -1. If 3 minus 1, which give me 2, give me what, -3/2, so it'd be 2 minus 1.5, which give me what, 1/2. And then for 4, I would have, what, 4 minus 1 would be 3, that would be what, so -1 plus 2, which would give me what, a 1. So if I plot these points, I'm going to go -5, 1, 2, 3, 4, 5. And then I go to 2.5, so I'm going 1, 2.5. And then I got 4 and 2.6. And then 3, 2.75. So actually it'll look something kind of similar to like this. And then I got 2. So I'm going to go 1, 2, -1, 3 and a half, 4 and 1. I can't be right with the 3.5. 3.5, so I got 3.5. 3 minus 1 is 2. So that's negative 1.5 plus 2 is 1/2, yeah. Now if I have 4, 4 minus 1 is 3. Gives me -3 plus 2 is, so that would be what? Yeah, I don't know. So this is where the graph comes in. Sorry about that, I had a little brain fart issue. My apologies. Something like that. Okay. Next, I have y equals 2 divided by x plus 4, all of which is plus 1. So if I go here, if I look at my domain in range, again, it's going to be all real numbers, except x cannot equal a negative 4. And here I have all real numbers except y cannot equal 1. So again, I'm going to get to write that again. So I'm going to go 1, 2, 3, and 4. And then, so those are my vertical and horizontal asymptotes. So if I make like an XY chart here, and let's say if I go -7, -6, -5, and I can just go -3, -2, -1. So if I plug these in, these are the values that I get for my y with my particular x values. Okay. So I'm gonna plot. If I plot those points, I go to -7 and a third. So it goes up here, and then 6 and 0, and then I have -5 and 1, and then it kind of looks something like this. Now I have -3 and 3 plotted here, -2 and 2, -1, 5/3. So it looks something kind of like this. So that is how you do it with the translation. Some of the graphs you're going to have to do will give you a general equation such as y equals ax plus b divided by cx plus b. So now we have a variable both in the numerator and in the denominator. So what dictates being able to find the vertical and horizontal asymptotes is this. So if I want to find a vertical asymptote, what I'm going to do is I'm going to take that denominator. Like, so say if I have an example A of x plus 2, I'm going to take what is x plus 2 going to be for it to equal 0. In this case, it's going to be x equals -2. So if x equals -2, that means that's going to be my horizontal asymptote. Or my vertical asymptote, I'm sorry. For my horizontal one, what you need to do is you need to find the coefficients of the values that are attached to the variable and divide them out. So in this case, it's going to be 3, and this is going to be 1. So I get 3 divided by 1, which equals 3. So my horizontal asymptote is going to be y equals 3. So when I draw this out, I'm going to find x is -2, which is right here. And then y is 3, which is here. And then I can plot my points to get my graph. So I'll just use -5, -4, -3. And I'll have what, -1, 0, and 1. And then I'll just, when I plot these points for x, I get y is 7, 9, 15, -9, -3, and -1. So if I plot these points here, I'm going to go, okay, 1, 2, 3, 4, 5, and then I got 7, which is somewhere right there. 4 and 9, so it's like up there, and then we realize that 15 somewhere up here, so make that line look something like this. Now I have -1, and -9, so look somewhere over here. 0 and -3, and 1 and -1. So it looks something kind of like this. And that is being able to graph simple rational functions. Hope this helps. Until next time.